Hello, welcome back to Sri Sai Tech Edu YouTube channel, Read Lead Success. We have already started with network analysis and control systems. That is module 1, first chapter is done in the previous videos. Now we are going to start with the second chapter, that is network theorems. We are going to study 4 network theorems, that is superposition theorem, Thevenin's theorem, Norton's theorem and maximum power transfer theorem. All these theorems have proofs. So the proofs are very important in this theorem and need to know the concept. Based on that you will be having problems to be solved. Now we will start with superposition theorem. Then the superposition principle is only applicable to linear networks and systems. Okay, the superposition is only applicable for linear networks. Linear networks. What are linear networks? We call y is equals to mx as a linear network. This is a characterized by an equation y is equals to mx. And m should be not a function of x. What it means? For example, you take y is equals to x cube. As you can see, m is equals to x square here. M is equals to x square. So what you will get, y is equals to x square into x, that is nothing but that is equals to x cube. Okay, so y equals to x cube you are getting. What is happening? It is affecting the x value. Why? Because this is power it is happening. It is not, you are not getting the same output. Here mx means we are not disturbing this x. It should not be a function of x. If it is 2x, okay. 3x, okay. It should not be x square. Then it will not be a linear function. So if you want to apply a superposition theorem, the network should be linear. Then there are some note points, that is the principle of superposition is useful for linearity tests. Yes, this is not valid for power relationship. Here we are not going to find any power relationship. It is not valid. Sources can be made inoperative by short circuiting the voltage source. As I've told in before, I've told you with example. No, voltage sources will be short circuited like this, and replacing them by their series impedance, and open circuiting the current source and substituting them by their shunt impedances. Okay. Then what is the fourth point? A linear network comprises independent sources, linear dependent source and linear passive elements like resistor, inductor, capacitor and transformer. It can comprise all this. Moreover, the components may either be time varying or time invariant. This time varying and time invariant, you just understand it, but in future time varying and time invariant also I'll explain. Time varying means the circuit varies based on the time. Time invariant means even based on the time the circuit will not change, like a capacitor or resistance will not change. You understand only this much still here. Proof based on loop analysis. Proofs are very important. Proof I have in this I have proved by 3 types. One is proof based on loop analysis and nodal analysis also. If you have not watched what is loop analysis and nodal analysis, there are videos, you can watch them, my previous videos. Loop analysis and nodal analysis I will prove, and also with using an example also I will prove the superposition theorem. First we will see using loop analysis. Consider a linear network N having L independent loops. There are N L independent loops. The loop equations are in the form of Zi is equals to E. Loop analysis, that is the general equation is Zi is equals to E, where Z is the order of, Z is a matrix, no, L into L, and I is in the order of L into 1, and L rows 1 column. E is also in the order of L into 1. The solution can be written as I is equals to Z inverse is equals to E. If Z is sent this side, you will get Z inverse into E. After doing that, that is equals to Z inverse is what? Y into E. Okay. Then you can write in this way. I is equals to summation J equals to 1 to L. Why? Because there are L rows we are considering and L columns. L Y I J E I J. This we are writing in the form of all, we are adding all the things, all the sources, like y into E means y into Yij into Ej, summation I is equals to 1 to L, to L rows or L columns. Okay. After that, applying the superposition theorem, making Ej is equals to 0 for all except j equals to k. See, we need to make inactive one voltage source. We need to keep only one voltage source active and remove all the voltage sources. That is nothing but making inactive. CEG equals to 0. Why? Because we want effect of one voltage source effect on the network. If there are many voltage sources, then keep one voltage source active and making EJ is equals to 0. All other sources except some J equals to, say, random one voltage source K they have to here need to be kept active, and for K equals to 1 to L, like L rows, and adding the individual responses. Then what we will get here, Y in the place of J, K, only one voltage source we are adding, no other voltage sources we are making 0. So only K. So YIK, EK we will take, in which is same as equation 9.2. It is same. We are making, but here all the voltage sources are considered. In this equation, all the voltage sources are considered. But superposition theorem states that we need to keep only one voltage source active at a time and see the effect. So we have took, for example, we have took J is equals to K. K is one of the voltage source where we are keeping active. So we have changed in the place of J as K. In other words, we first assume all EJs except E1 to be 0. Or all EJs except E1 to be 0. This will give the current in loop 1. It will give the current in loop 1. In the loop 2 as Y21 and E1 etc. Okay. Similarly, when all source except E2 are made inoperative, if except E2 all are made inoperative, it will give the current in loop 1 is Y12 E2, loop 2 is Y22 E2, and so on. This continues. Whenever we make one voltage source on, we get that respective loop currents. The procedure is repeated in turn for the remaining sources E3, E4 till EL, and the corresponding loop response is determined. On applying the superposition principle, individual responses are added. After getting the effect of all the voltage sources, their effect, then what we do, we'll add up. I1 is equals to Y11 E1 plus Y12 E2, second voltage source, then Y12 E2, then Y13 E3, Y14 E4. How many voltage sources are there? Those many voltage sources into their admittance. We'll multiply and we'll add up all the things. Then we'll get the current, which is the same as that obtained by solving simultaneous equations. So, it's superposition theorem. We take one voltage source active. Like that, we take, if there are n sources, each time we will take one voltage source active and making other voltage source 0, and individual responses will be added up based on this formula. That's it. This is what you need to write in the proof. This is based on loop analysis. Now we will see based on nodal analysis. Nodal analysis means based on the nodes. They are based on the meshes. On a similar line, the proof based on the nodal analysis can be given. Let a linear network N have L plus 1 nodes. Here meshes no. Here there are nodes. So L plus 1 nodes. The node equations are summation j equals to 1 by ij. Ej is equals to I. The same formula they have used here also. Then what we need to do, y is equals to I, that is y equals to a generalized form. The solution of 9.3 is E is equals to, if you send y this side, y inverse I, you get y inverse I, that is equals to zi. You will get zi. Ei is equals to summation j equals to 1 to L jij into ij. Here we will consider the zij into ij. Assuming all ij's to be 0. Nodal analysis, it will be in the form of V is equals to Ij. So, to J, for example, here what they are telling, here current sources, nodal analysis is based on current. There why we have took Ej, because mesh analysis is based on the voltages. Nodal analysis is based on the current passing through, no. So, current Ij, current source is made all Ij's, all the current sources are made 0 except one current source. Like here where what we are doing, one current source is kept active every time, other current sources are made 0. And we will see the effect of the voltage. Ei is equals to Zip into Ip. Why? Because we are taking Z is equals to P. For assumption we are taking Z is equals to P. There is one P called as one P current source. That P current source is active. So we are taking P. We will take like that. If there are n current sources, n current sources separately we will consider. Then for P is equals to 1 to L. Okay. In between there is come P is equals to 1 to L. Sorry. P is equals to 1 to L. That is but nothing but L rows. I is equals to 1 to L. Okay. Then on applying the superposition principle, the individual responses are added together to give the resulting response. The individual responses, like if you want E1 is equals to Z11 plus Z11 I1, okay, plus Z12 I1 plus Z13 I1, so on it will be taken till L. So 1 current, for example, if this current source is made active, these all will be 0. So we will get this. Then the first current source will be made inactive. In the same way, all the current sources we will get and will add up in this way, the shown way. That is what they are telling in this line. On applying superposition, the responses are added together to give the resulting response. So EI is equals to P equals to 1 to L ZIP EP, which is the same as obtained by solving simultaneous equation. There in mesh analysis, we considered voltage source to keep one voltage source at a time to be active. Here current source is taken as active, one current source in terms of current. Okay, nothing, no difference. Proof based on nodal analysis and mesh analysis. Based on the marks, you need to write proof. If they ask superposition theorem based on the nodal analysis, do only based on the nodal analysis. If they ask superposition theorem to be proved, then better to, if it is for 10 marks, then do proof based on nodal analysis and mesh analysis. Both you write, then you will get good marks. And it is anyway easy if you understand the concept. Superposition theorem we will solve with an example network, so you will understand still more easily. If you see this figure, apply KVL in mesh 1. If you see, there are 3 resistors and 1 voltage source, See, if you see in B, what it is happening, we removed 1 voltage source and shorted. Voltage source will be shorted. Like we are seeing the effect of this network, how this voltage source is affecting this network. Then what we will do, we will short the first voltage source and we will keep active second voltage source, and we will see the effect of this network. That is what is done. After that, what we will do, we add the network of B and C, the effect of B and C. We will get the total effect of these 2 voltage source on the network. Understood? Separately we are doing, that's it. How we should do? First, write the apply KVL to mesh 1 and mesh 2. How you will apply? Initially, we will consider whole thing. Okay, 0 equals to E1 minus I1 Z1 minus Z3 into I1 plus I2. Why? Here if you see, here in the question, in the example, current is moving this side, current is moving this side. If you see, the both currents are moving in the same direction. They are not taken both in clockwise. This is clockwise and this is anti-clockwise. So, as the currents are moving in the same direction, we need to add them up. Before in mesh analysis and nodal analysis, in mesh analysis, we have seen if the current is moving in the same, if it is moving, for example, in this, what happens? The current will be in this opposite direction. So, we used to do I1 minus I2. But here, one is taken in the clockwise, another one in anti-clockwise. So, both currents in the Z3 are moving in the same direction. If you see here, see, same direction. So, I1 plus I2 you will take. After that, you will get some equation. In the same way, you will write for the second mesh also. After writing, on solving equation 1 and 2, you will get I2 is equals to E1 minus, from equation 1, I2 is equals to E1 minus I1 Z1 plus Z3 minus I1 Z1 plus Z3 by Z3. Putting this I2 equation in this equation 2, you will get, what you will get? You will get the I1 current. I1 current means mesh 1 current. If you substitute, I have solved all the things because it should not be tough for you. you should understand how the steps go. So I've put all the steps, but for explaining, I'll explain in this way that you'll understand. See, we are substituting from this equation, we are taking the I2 and substituting in this so that you will get I1. Okay. In the same way, we want I2 also now. Now we got I1 as this. Okay. Now we will take from equation 1, I1 we will take. I1 is equals to E1 minus I2 Z3 by Z1 plus Z3. Put I1 in equation 2. Initially we have took I2 terms, but we have took now in terms of I1 and put in the equation 2. What you will get now? You will get I2. The current I2 you will get. Okay. Till here it is same as mesh analysis. Now we should see how superposition can be applied. If you see in the figure B, E2 is made inoperative as I told. Then after doing that, you write the apply KVL for this mesh 1 and mesh 2. You will get these two equations. If you do. Then after doing that, what you will get? I1 dash is equals to this. You will get I2 dash will be this. Okay. Then here why we have to I1 dash and I2 dash is to just know that we are making this voltage source inoperative. So we are changing the way we write the I1 and I2 so that representation will be good, so that it will be easy for us also. This is where E2 is inoperative. So I1 dash and I2 dash. Now making E1 inoperative, making 0. Then you will get by KVL, you will apply, you will get two mesh currents. Then I1 dash and I2 dash, how you will get as this. Okay, I1 dash and I2 dash. Now if you want the I1 current, what we need to do? I1 dash, 1 minute. Now if you want I1, what we need to do? I1 dash plus I1 double dash. You will get I1. If you see carefully, if you add this and this, the before what we have done, we have applied mesh currents, mesh analysis for this both, no, without making inoperative. You get the same equations. If you add this and this, I1 dash plus I1 double dash, you get the same equation before in before slide. I1 dash for I1. For I2 current, if you add I2 dash and I2 double dash, you will get the same equation what we got by applying the mesh analysis to the EA network. What it means? That superposition theorem is proved. What we are proving here? That if we apply separately mesh analysis to this whole network also, we will get the effect of the voltage sources on the network. But superposition theorem, to make it easy, what we will do? We make one voltage source inactive and find the effect of the voltage source on the network, and we make another voltage source in the next topic and next step, and we will see the voltage source effect on the network. Then we add up these two we add up, like the effect of the this and this, then you will get this itself. So that is what is proved in superposition theorem. Initially we took mesh analysis. Initially what I've shown in previous slide, we got the same equations when you add I1 dash and I1 double dash. If you add and see, and if you compare with the previous slide, you will get the I1 current itself before, and I1 double dash, I2 double dash and I2 dash, if you add also, you will get I2 current only. Okay, here separately we are seeing in superposition theorem. That is the difference. We will be having some sums also on this. We will see now that. For the circuit of figure, use superposition to determine the unknown branch current Ix. We want unknown branch current Ix. Okay. Here see, there is one voltage source, one current source. First what we will do, we'll keep a voltage source active, and current source will make open circuit, and later on we keep current source active and make voltage source inactive. We will see how to do that using superposition. First, eliminate current source. After eliminating current source, what happens? Current source will be open circuited. Then after open circuited, we want Ix dash. Why? Because it is better if you change the naming so that it will be easy for you. Then again you can add up for the effect of the voltage source and current source, and you can get the final current answer. Here you take as Ix dash. Okay, Ix dash, you will get, apply KVL, what you will get, 3 plus minus 6 Ix dash. Why? Because we take Ix only here, as current here moving is Ix dash. So we take Ix dash only in the clockwise direction. Then plus minus, you will get minus Ix dash. Minus Ix dash equals to 0. After taking, what you will get, 3 is equals to 15 Ix dash. Ix dash is equals to 0.2 amperes. Initially, we have removed the current source and we have seen the effect of the voltage source on the network. Now what we need to do, we will remove the voltage source and see how current source will be acting on the network. We remove the current source and we will see the current source, how it is acting on the network. How we need to do that now? Here what we can do is, we can apply current dividing rule. Current dividing rule is very easy. If there are two resistors in parallel in this way, and if you want current in what, in if you want current Ix double dash, here Ix double dash in this 9 ohms, what we need to do is, first Ix double dash, we want Ix double dash in 9 ohms. 9 ohms Ix double dash is equals to, the whole current is what, 2 amperes into the opposite current, the opposite resistance we need to consider, 6 by 9 plus 6, addition of 2 resistances, 9 plus 6. Then you will get Ix double dash, it is 0.8 amperes. Once again I will repeat the current dividing rule. Current dividing rule is nothing but, if you want a current, for example I will show in with another example. If you want, if there is a current source like this, if this is the whole current and this is R1 and this is R2, if you want current through R1, what we will do? Current through R1, I is equals to current through R1, we'll mention in this way, I R1 is equals to, if I is given, I total, it is I total, you think. So I total, the total current I total into the opposite, we want in the R1, current in R1. So we should not consider this here, we need to consider R2. So R2 by R1 plus R2. The opposite current we need to consider. Here I hope you understand. Once again I will explain that example. With that example you will understand. Here if you see, here the main total current 2 into, we want current in this 9 ohms. But so we should not multiply with that. We should multiply with the opposite current, that into 6 by 9 plus 6. Current dividing rule is like that only. Then you will get Ix double dash. You will get 0.8. If you are getting confused with it, what you can do is, you can take a mesh analysis in both sides or nodal analysis, and you can get easily the Ix double dash. Anyway, here directly it is simple network. No, you can directly use current dividing rule. It will be easy. You got now Ix and Ix double dash. Ix dash is what? Where the current source is eliminated, the voltage source effect of the network, and Ix double dash is the voltage source is removed and current source effect on the network. If you add them both, you will get the Ix, the total Ix in the 9 ohms. How you will get? See, therefore Ix is equals to Ix dash plus Ix double dash, 0.2 plus 0.8. Ix is equals to 1 ampere. You understood now, I think, superposition theorem. You will see some more sums, you will get still more clarity. Superposition theorem. Here again we need to find, using superposition to compute Ix in this 15 ohms we need to find. Okay, we will do that. See, first what we did, we short circuited the voltage source. Okay, then we kept current source, anything. First you can take current source active or voltage source active, or voltage source active first and then current source active. It is your wish, but initially I have to here current voltage source inactive, and 2 amperes, and if you see these two are in series, 7 and 3, so you will get 10 ohms. Then 15 ohms is same, Ix dash, you will take it as Ix dash here. Why? Because just to know, like we need to add again, no? So Ix dash you take here. Then 5 ohms. As I told in previous videos also, if there is a resistance with the parallel short network like this, then the resistance can be removed. So that is what I did there. I removed that resistance This resistance is not required, so put that just a short. Okay, if only one resistance is connected in parallel, then only you can remove that resistance. Okay, then if you want Ix dash in 15 ohms, what we can do? Again apply current dividing rule. It's very easy. Ix dash is equals to total current to how much it is going? 2 amperes. 2 into, we want current in Ix dash, so we should not consider this resistance, we need to consider the opposite. So into 10 by 10 plus 15, then you will get Ix dash is equals to 800 milliamperes. Now we got one effect, current source effect on the network. Now we want voltage source effect. Then what we can do? You remove this current source by open circuiting it. After open circuiting it, what you will get? Ix double dash you take here, and this 10 ohms, 5 ohms and 3.5, and this will be common. Then what you can do? You take this, as this current is Ix double dash, you consider the clockwise direction Ix dash in mesh 1, and in mesh 2 you take something I0 or I1, your wish. I have took here I0. Why? Because we want Ix double dash. Applying KVL to mesh 1, what you will get? Minus 10 Ix dash minus 15 Ix double dash minus 5 into Ix double dash minus I0 equals to 0. You will get first equation. Then apply mesh analysis to the second equation, that second mesh. It is mesh 0. I took mesh 0, so 0. Then you will get another equation. If you use Gaussian find, you will easily get the unknown of the Ix double dash. Ix double dash will be 140 minus 140 milliamperes. To get the total effect of the current source as well as the voltage source on the network, you need to add up Ix dash plus Ix double dash. 800 milli minus 140 milliamperes, you will get 660 milliamperes. See, it is very easy. We need to remove one voltage source or current source and find the effect, and again keep the other one which is not kept active, and you get the other current. Added them, you will get the current across some whichever they asked, in which resistance they asked. If you see here, determine superposition principle to determine the value of X. Use the superposition principle to determine the value of Ix. What we need to do here? Remove the current source first or voltage source, then find the net effect. Then if you are removing first voltage source, then next you remove the current source, then see the voltage source effect. First I have removed the current source. After removing the current source, we open circuit it. After open circuiting it, what will happen? If already they have given it as Ix, so I will take Ix only as the current, and it is going in the clockwise direction. Take Ix dash 10 volts, 2 ohms, 1 ampere, 1 ohms and 2 Ix dash. Change here also. Why? Because this is depending on this dependent source, no? So it is depending on the Ix. So take in the place of 2 Ix dash 2 Ix dash. Okay. After that, apply KVL. As you know KVL, you can easily apply 10 minus plus minus minus 2 Ix dash plus minus minus 1 Ix dash plus minus, end value is minus, so minus 2 Ix dash is equals to 0. You will get Ix dash is equals to 2 ampere. Then what we need to do? Then you remove the voltage source by short circuiting it, and keep the current source 2 ohms and 1 ohms. Ix dash, Ix double dash you take here. Here also you take 2 Ix double dash. Then after that, what we need to do? Apply KCL. Here we are taking KCL, nodal analysis. So it will be easy. As if you see, they have given in the question, there is some voltage across the current. There will be some voltage across the current. They have mentioned no. So directly you can take that node as V. Take this node as V and apply nodal analysis. If you see, this current is going towards the node, and if you take this is going outside the node, then incoming nodes, addition of incoming nodes 3 amperes is equals to outgoing node is V minus, here it is will take 0, no? So V minus 0 by 2. Here it is V minus 2 Ix dash, 2 Ix double dash by 1 ampere. Okay, Ix double dash by 1 ohm. So what you will get? 3 is equals to V plus 2V. If you take LCM, 2V minus 4 Ix double dash by 2, you will get 6 is equals to 3V minus 4 Ix double dash. Now you know where V is equals to what? V is nothing but 2 into minus Ix double dash. How? I'll tell you that. V is equals to across V. If you want voltage across 3 amperes, what we need to do? V is equals to IR. No. Here I is what? I is the IR. Sorry, let me correct. That is not V equals to IR. Here V is equals to, we can take across this voltage, across the voltage across this 3 amperes. How we can do is, this is the nothing but 2 into bracket minus 2 into minus Ix double dash. We need to take. So if you substitute V is equals to 2 into minus Ix double dash. Why? Because current is flowing in this way. So minus they are taking. So you will get Ix double dash as minus 0.6 amperes. Now you got Ix dash and as Ix double dash. Then Ix is equals to Ix dash plus Ix double dash. Then you will get Ix as 1.4 amperes. For the circuit of figure, use superposition to obtain the voltage across each current source. By using superposition, what they are asking is, we need to find the voltage across each current source. This is one current source and this is one current source. They wanted the voltage across each current source. This is V1 and V2 they want. In the question what they have asked. Here V1 and V2 already they have mentioned, and the reference voltage 0 is also mentioned, 0 ground. So we can directly start the question. If you see here, first what I have done is, first I open circuited the current source. That is, I made current source inactive and voltage source active. The dependent source we cannot remove, so we need to keep that dependent source like that itself. Then plus minus 3 volts, 7 ohms. V1 dash we will consider. Till now we have seen the currents. Now we will see voltage. How to perform node analysis here. V2 dash we need to find V1 and V2, not I1 and I2. V1 and V2 we need to find. So V1 dash and V2 dash, and 15 ohms. 5 ohms is same, the current I and 4I. After that apply KCL to node 1. That is node analysis. We want to apply, first initially we will apply at node 1. Here we will apply here. So as if you can see, at node 1 there is no incoming current, any current going inside. There is no, so 0 equals to V1 dash minus 3 volts by 7 V by R. No, so V1 minus 3 by 7 plus V1 dash minus V2 dash by 50. Okay, you need to take in this way. Then you will get 0.429 is equals to 0.209 V1 dash minus 0.067 V2 dash in terms of V1 dash and V2 dash. First equation. Then apply KCL to this node 2. If you see, there is a current going inside, summation of the incoming currents, that is 4I, and outgoing current, take this as 1 and take this as 1. Then take V2 dash by 5 plus V2 dash minus, we are taking with respect to V2. So we need to consider first V2 dash minus V1 dash by 15. Here we are taking with respect to V1, so we are taking V1 dash minus V2 dash. But here with respect to V2 dash minus V1 dash by 15. So where I1 is equals to, we want I value. We don't know I value. So we want to know I value. How we will get? If you see the current passing through this 5 ohms is V2 dash by 5. So substitute V2 dash by 5 in this, in the above equation. So you will get this equation. Then you will get V1 dash and V2 dash in terms of V1 dash and V2 dash, second equation. If you use calci and phi, solving 1 and 2, you will get V1 dash and V2 dash. We got. Now what we need to do? Now we already made current source inactive. We have seen how voltage sources affecting the network. Now we will make voltage source inactive and see. We made voltage source inactive and made short circuited. As you can see, there is no 3 volts here. Then 2 amperes we have took V1 double dash, V2 double dash for notation. 15 ohms, I, 5 ohms, and 4i. Same, other circuit is same. Apply KCL to this node 1. If you see there is a current going in towards the node, that summation of incoming nodes will be equal to summation of outgoing nodes. If you take outgoing node as this one, V1 double dash by 7, and outgoing node from this node is V1 double dash minus V2 double dash by 15, you will get first equation. Then applying KCL to node 2, if you see there is an incoming current, that is 4i. 4i is equals to outgoing. Outgoing you can take V2 double dash by 5 and V2 double dash minus V1 double dash by 15. After considering this, you will get two equations. The second equation is also after doing calculation and replacement, you will get in terms of V1 dash and V1 double dash and V2 double dash. Calculating what you will get, V1 double dash calculating these two, you will get V1 double dash and V2 double dash values from here. After getting that, V1 is equals to V1 dash plus V1 double dash. V2 is equals to V2 dash plus V2 double dash. Here I forgot to put the values of the V2 double dash and V1 double dash, but here I have mentioned. If you see V1 dash plus V1 double dash, V1 we got as how much? V1 dash we got 1.967 and V2 dash we got as minus 0.246 and V1 double dash we will get as 9.180 and V2 double dash will get as minus 1.148. If you do with calci, you will get. Then after that you will get V1 and V2. V1 is nothing but respectively. V1 is separate, we got V1 dash and V1 double dash. V2 separate, we got effect of V2 dash plus V2 double dash. We need to add them both, then we will get V1 and V2. It is not only single current. No, there are two nodes they are asking. So separately for V1 and V2 we need to calculate. Analyze circuit and demonstrate that Vx is equals to Vx dash plus Vx double dash. Nothing but keep one source active, another source inactive. Here also keep one source active, another source inactive. What we have done previously, in the same way apply superposition theorem. If you see, I have removed here, there are both voltage sources only. So I made this voltage source inactive first. So I made that as short circuit. If you see, there is no voltage source here and 1 kilo ohm and as here it is Vx dash. Here it is Vx, you take initial as Vx dash. If this is Vx dash, you can consider this node as Vx dash itself. If you consider, you can consider anything, but if you consider Vx dash, it will be useful. And again, no need to tell that Vx dash is equals to so and so node. If it is anyway, they have given the potential across this is Vx double dash, so the same potential will be here. So Vx dash you take. Then apply KCL to node X. So if you see here, if you see, adding all the currents, there is no incoming current, so you take all as outgoing currents only. Then Vx dash minus 12. If you take this difference to 0, Vx dash minus 12 by 1000 ohms plus Vx dash by 3000 ohms. Then Vx dash by Vx dash minus 0 it is. Why? Because there is no voltage connected to it. There is 0 volts. So Vx dash minus 0 by 2000 ohms, that is equals to 0. If you calculate, you will get Vx dash. Vx dash is 6.5431. Then now what we will do, we will make 12 volts as inactive and minus 15 volts as active. After making this, again apply KCL to Vx double dash node. Now we will consider it as Vx double dash. Same way, Vx double dash by 1000. Vx double dash by 1000. Why? Because there is no voltage source here. Plus Vx double dash by 3000. Then Vx double dash minus 15. Minus of minus 15 it is. Why? Because minus 15 they have given by 2000 equals to 0. Voltage drop across 2 points, we need to minus it. V1 minus V2. So here it is Vx double dash, here it is 15. So Vx double dash minus of minus 15. No. So Vx double dash plus 15 it will become. Minus of minus is plus. Then after that, if you calculate, you will get Vx double dash. Vx double dash is equals to minus 4.089. If you want Vx, what we need to do? Vx dash plus Vx double dash, effect of the separate sources. If you add, you will get the total effect of the both the sources. So Vx is equals to 2.4541 volts you will get. So these are the different sums I have solved. It is easy, and superposition theorem, some practice questions also I am giving. Practice them. The same similar type of questions only I am giving. If you see here, first inactive the current source, then inactive the voltage source, and find the separate effect of the both the current source and voltage source, then add up. Okay, I8 dash and I8 double dash, like that. Then here also same, like this sum also have solved. You can compare and solve them. And this is one more question. Same way, this sum previously only have solved similar sum. You can solve them and we can easily find out. The answers also have been given. I'll stop the video here. In network theorems, we have completed the superposition theorem. There are still more 3 theorems, that is Thevenin's theorem, Norton's theorem, and maximum power transfer theorem. I will upload the next topics video separately. Thevenin's theorem separate, Norton's theorem separate, and maximum power transfer theorem separate. Till now, superposition theorem is done. We are left with 3 more topics to complete module 1. I'm stopping the video here. If you have any doubt, please do comment in the comment box. If you want any other topics or any other question doubt also, you can comment in the comment box. I will solve and send it. And I will, once the module 1 is complete, I'll start with the module 2 also. Now till now, still more 3 topics are left for the module 1. Thank you. From Sri Sai Tech Edu YouTube channel, read, lead, success. Keep reading.